There is a ton of stuff in the world that is theoretically true. Equations were created by mathematicians and physicists so that people who knew that some things were true could work out that other things were true too. In the equation developed by Erwin Schrödinger in 1926, someone who knew how the electric field around an atom's nucleus changed could work out the probability of finding an electron around that nucleus at a specific location or time. There is a higher probability of finding electrons in places to which they are more attracted. This whole idea of finding electrons can be compared to digging around in your sweets jar trying to find a red sweet without looking. The electric field is like the arrangement of sweets. If you know that you always put the starbursts in first, then the strawberry laces, and then the minstrels, you can plot the varying probability of finding a red sweet like this. Strong electric field, high probability of finding red sweet. This could also change with respect to time if someone was eating the sweets. But why does he use a wave function? The diagram says that particles in waves move like this. I say that molecules and atoms, along with their electrons, move like this. Different wave functions lead to different movements, which mean different molecules. He started with the conservation of energy and rearranged the equation. Then he developed a wave function that he thought obeyed the laws of nature. 1. It had to look like a wave. 2. It would depend on position as dictated by its wave vector. 3. It would depend on time as dictated by its angular speed. He wanted to find out exactly how this wave function changed with time and position. This is done using a technique called partial differentiation. He took the results of the partial differentiation and swapped some variables around using equations by Planck and de Broglie. These letters with hats on are called operators. They are like verbs because when they are put next to wave functions, they require something to be done, for example differentiation. Anyway, back to the point. Schrödinger had just made operations for total energy and momentum. He stuck them back into the conservation of energy equation and rewrote them in their full form.